Okay, so welcome. So now what we're going to do is we're going to talk about other techniques for integration, specifically talking about integral tables and also what we call computer algebra systems, or CAS. Okay, so I'm going to spend most of my time talking about the integral tables, and I'll show you one using the CAS, but it's not going to be directly using a calculator or the computer, but I'm going to show you where to go to do it. So I'm going to tell you where to go. So again, there's a lot of useful resources online. Okay. So integral tables. Integral tables are lists of integral formulas, integration formulas. So basically it tells you, hey, if it has this form, if the integral has this form, then the antiderivative is going to be this. Okay. And so you can find these anywhere on the internet. Every textbook of calculus has them in the back of the book cover or the front cover or both, or there'll be a trifold, an insert of some sort where you can unfold it and you'll have a list of all of its different types of integration or integral forms. Again, it's not going to be exhaustive because there are literally thousands. So, but you can find many of them online. Okay, so I'm going to do examples of how to use those. Why? Because they're easy to use. They're good for a quick to check or to evaluate integrals quickly, and again, they're very helpful. Okay, very much like the CAS on your calculator or online. You can find those online or on your computer. Okay, so for example, let's do an example of something like this. So this is an example of something you would find in an integral table. So if your integral has this form, so where a is some constant, u is some function, and if it fits this form, or you can make it to fit this form, then you know that the integral is, the integration of this, the antiderivative is going to look like this, where you just plug in u and a. Okay, so if it fits this form, then it's very easy to evaluate it quickly because you just plug in the pieces here. Okay, so let's do an example. Let's say we have something like this. Okay, so let's say we have something like this, and we want to integrate it. Okay, so it has the form here, so, and there are many integrals on the integral tables that have this form of a squared minus u squared. Okay, so also we have this du, so just keep in mind that we also have to fit this du here. Now, the only thing that I notice here is that in this case here, we don't have e to the 2x. We have, doesn't match here. Okay, but let's see what our u substitution would look like. So u seems to be e to the x. Okay, a is 4. So what would du be? Well, du would have to be e to the x dx. Okay? Now, the cool thing about this is that I've got e to the x here, but I need e to the 2x. I need it to be squared, right? So if I write this a little differently, let's write this so that's more obvious what a and u are. Okay, so I've got u is e to the x, but here I've got u squared. Okay, I need a u squared in the bottom, but I also need e to the x dx if I have du. So what I'm going to do is I'm going to multiply the top and the bottom by e to the x. And so why? Because I need e to the 2x here, but also that's going to give me my e to the x dx for my substitution. So now this becomes that. And I didn't change anything. All I did was multiply by a form of 1. So I can rewrite this. So now I got it into the form I need. Now u is e to the x, a is 4, and so now all I have to do is plug it into this, and I'm done. Okay. Now if you want to write it as in u substitution so that it's this, right, you could do this and just say, okay, well this does fit the form, so it'll be 4 squared minus u squared over u squared du, right? So a is 4 and u, right? And so if I write it in this form, then I get negative 4 squared minus u squared over u minus inverse sine of u over a, which is u over 4, plus c, but then I'm just going to have to plug back in what u is, right? So once you get to this part, you're done, but then you just stick back in what u is. But if you already know what u is, right, so this is my du, this is my u, and this is my a, then you can just go ahead and do it directly. But let's go ahead and do this. So it's negative 4 squared is 16, so we get 16 minus u squared, which is just going to be e to the 2x, divided by what? E to the x, minus inverse sine of e to the x over 4 plus c. And that's it. So see how it makes it very easy using things from the integral table. All you have to do is take what you have, find something that almost matches or exactly matches what you have in form, and then all you have to do is use the table and just go right to the answer to evaluate it. Okay, that's it. Let's see if we have one for you. Okay, I'll see you next time.